Hi everybody, this is section 1.5 and it's about intersections, unions, and compound inequalities. And many of you, if not all of you, are probably familiar with some of these concepts, intersections and unions of sets, from high school and middle school. But of course here we'll investigate it in more detail, and then compound inequalities. Again, some of you have seen that before. But anyway, we'll go through all the details here, and here are the three objectives of section 1.5. A, find the intersection of two sets, solve and graph conjunction of inequalities. And B, find the union of two sets, solve and graph disjunctions of inequalities. And then the third part, C, solve applied problems involving conjunctions and disjunctions of inequalities. So this may sound a little bit wordy, but as we do some of the examples, you'll see that's relatively simple. And so you'll be able to understand what we'll be talking about here. Of course, that presupposes that you're reading the chapter also. Don't just go by the video lectures, but together, from reading the book and watching this lecture, you will definitely understand the topics. We start with the basic definition of what an intersection of two sets is, and that is the set of all members that are common to both set A and set B. And we denote the intersection of two sets A and B by A intersection B. That's what it looks like, and that's how we read it. Graphically, I'm sure you've seen this before, when you have two sets, the set on the left, set A and set B, then what they have in common, this middle portion here, that is A intersection B. In other words, these elements are common to both sets. So let's apply that to a simple little exercise here, and that is find the intersection of set 0, 3, 5, 7 and set 0, 1, 3, 11. So when you look at these two sets, the question really is, which elements are in both sets? Well, 0 is in both sets, so that's certainly part of the intersection of these two sets. And then 3 is in both sets, so then we can say that the intersection of these two sets is 0, 3, and let's see what else there is. 5. Well, 5 is not a common element to both sets, and neither is 7 or 11. So that is the intersection of these two sets. The next exercise asks to shade the intersection of sets A and B. Well, the rectangle is A and the ellipse is B. And so which elements do they have in common? Well, we can shade in this area here because that's common to A and to B as well. So it's relatively simple to do that. Here is the intersection of the two sets. All these elements are in A and they're also in B. That is the intersection. So we can say that this is A intersection B. Next, let's talk about conjunction. And that happens when two or more sentences are joined by the word and to make a compound sentence. The new sentence is called a conjunction of the sentences. For instance, here we have A less than X and X less than B. It can be also abbreviated as A less than X, X less than B. In other words, two conditions have to occur in a conjunction, two or more conditions. Similarly, B greater than X and X greater than A can be abbreviated as B greater than X, X greater than A. So that's notation. So let's apply that to exercise number 3, where we have the conjunction 1 less than X and X less than 4. So we're supposed to graph and write in interval notation what that looks like. So the first statement, x greater than negative 1, we go to negative 1 and then we go to the right. All numbers that are to the right of minus 1, that's what this statement says. And then the other condition is x less than 4. So we go to 4 and then we look at the numbers that are to the left of 4. So in other words, this would be the graph of this conjunction. And in interval notation, parenthesis, negative 1, comma, 4, close parenthesis. So that's the interval notation for this conjunction. Then we can look at example or exercise number 4. So here the statements are combined. What this really means is that minus 22 is less than 3x minus 7, and 3x minus 7 is less than or equal to 23. So how do we solve this conjunction? Let me explain the details.
$60. Just gonna eat this, and then I'm gonna go back out again. Yeah, I wanna get up to 100 at least. Mom is busy. I just come here to have a quick snack. Quick dinner. No, here's the thing. It's gonna make me pee a lot, and I'll be very unproductive, and I can't go anywhere. It's gonna make me go bathroom. Yes.
Wash your hands, Robin, because
I did. I walked through that. I walked through that in the bathroom.
Hi, Robert.
are you saying the truth?
Hi, Robert.
Veggie pizza, Mom. Only veggies.
Hi, Robert.
Hi!
Oh my
I'm
God.
talking to my mother.
You can just hi.
Hi, Dad.
Thank you. Okay, so I'm recording here, so if you can keep it down a little bit, I'd appreciate it, okay? Thank you. Following example 2 in the book, we can rewrite this as minus 22 less than 3x minus 7 and 3x minus 7 less than or equal to 23. So we add 7 to both sides. So it gives us a minus 15 on the left and a 3x on the right. Then we divide both sides by 3, and we wind up with negative 5 less than x. Then on the other side, we would add 7, and then we only have 3x here, and 23 plus 7 is 30. Then we divide both sides by 3, so we have x less than or equal to 10. So we can combine these two statements as minus 5 less than x less than or equal to 10. Okay? So when we graph this, we go to minus 5, which would be here, and that gets a parenthesis because it is inequality. X is greater than minus 5. So we get a parenthesis here. And we go to 10, which would be here, and that gets a bracket because we have less than or equal to 10. And then we graph a line between these two end points, and that would be the graph of the solution to this conjunction. So I rewrote the solution next to the problem statement, and so you have the solution and the graph. Notice in this example that did not require to write the solution in interval notation. For example 5, we are supposed to solve and graph this conjunction here. So we solve the first inequality, 3x plus 4 less than 10. We solve that by subtracting 4 on both sides. So we get 3x is less than 6. Then we divide both sides by 3. So x is less than 2. The other part, we have 2x minus 7 less than minus 13. So we add 7 to both sides of the inequality. So we find that 2x is less than negative 6, or x is less than negative 3. So that means x is less than 2, or the numbers to the left of 2, and they have to be to the left of minus 3 also. They have to be less than minus 3. So that means that only this condition can exist. In other words, all the solution set is this one here. Because if we picked a number, let's say like 0 or 1, that would not satisfy the second inequality. And so therefore that's our solution here, this graph here. And so it's the set of all x's such as x is less than negative 3. That would be the set builder notation. Next, we have the concept of the empty set, and that is when we have disjoint sets. So sometimes two sets have no elements in common, but in such a case, we say that the intersection of the two sets is empty, is the empty set, denoted by this symbol here. Typically, this is what you see most of the time. Of course, you see this one also sometimes, but this is more common. It's a circle with a line through it. In other words, it's not a 0 with a line through it, it's a circle. So A intersection B equals this symbol means the A intersection B is the empty set. So when we use this symbol, we don't use braces to indicate a set. This symbol itself stands for the empty set. Okay? So let's do an example of that. Let's look at number 6, and let's solve that one. So here we have the two inequalities. We add 7 to both sides. So that means we have 3x is less than or equal to minus 6. Or by dividing by 3 on both sides, we find that x is less than or equal to negative 2. Okay. On the right side, we subtract 3 on both sides. So we get 4x is greater than 5. And now we divide both sides by 4. So x is greater than 5/4 or 1 1/4. Graphing these two solutions, we find that x less than or equal to negative 2 would be this graph here. And the other one, 5/4, is about here, 1 1/4, so it gets a parenthesis because it's strict inequality. So when you look at these two sets, the x less than or equal to minus 2 and x greater than 5/4, they have no elements in common, so the solution set is the empty set in this case. Let's look at the compound inequality in example number 7. So in the past, we would have written this as minus 4 less than or equal to 8 minus 2x, and as 8 minus 2x less than or equal to 4. And we would have solved them separately and then combined the solutions. But there's a more elegant way of doing this, and that is the purpose of this guided solution. So we have minus 4 less than or equal to 8 minus 2x less than or equal to 4. Now again, the idea is always to isolate the term with a variable, and then at the end the variable itself. So to eliminate 8, we need to subtract 8 in each part of these inequalities. So therefore it becomes minus 4 minus 8. And then here we have 8 minus 2x minus 8. And then on the right side, we have 4 minus 8 also. So we're subtracting 8 in each part of the inequality. That's the important thing to realize. So minus 4 minus 8 is minus 12. And in the middle, 8 minus 8 is 0, so we only have minus 2x. And on the right side, we have 4 minus 8. That would be minus 4. Now, to isolate x, we need to divide each term of this compound inequality by negative 2, the coefficient of x. So we divide minus 12 by minus 2, and we divide minus 2x by minus 2, and we divide minus 4 by minus 2. But remember that when we multiply or divide an inequality by a negative number, we need to change the direction of the inequality symbols. So this then becomes greater than or equal, and this has already been changed, this one here, they did that for us. And then on the left side, a minus divided by minus is a plus, so 12 divided by 2 is plus 6. And then now here in the middle part, the minus 2 is cancelled. We only have our x, which was the idea in the first place. And then minus 4 divided by minus 2 is positive 2. And typically you have the inequality symbols go the other direction. So it would be x greater than or equal to 2 and less than or equal to 6. So we just flip it around. So the solution set is the set of all x such that 2 is less than or equal to x, x less than or equal to 6, or bracket 2, 6 bracket because we have inequality with an equal sign underneath. That's why we have brackets for the interval notation. So here we have set notation and here we have interval notation. The next topic we'll be discussing is a union of sets and the disjunctions of inequalities. And again, you've probably seen the union of two sets A and B before, and that is a collection of elements belonging to A or B, and or B. So we denote the union of A and B by A union B. It's simply like a letter U almost, but it stands for union. And so let's look at example number 8, how we can apply that. So here we are asked to find the union of two sets. The first set is 0, 1, 3, 4, and 0, 1, 7, 9. So the union is simply all the elements. And so we have 0, 1, we have 3, we have 4, we have 0 again and 1 again, but we don't write that again because it's already in that set. And then we have 7 and we have 9. So that's the union of these two sets. Very simple. In exercise 9, we're asked to shade the union of the two sets, A and B. And so that simply all the elements in A, we shade all of A, and we shade all of B. So that's the union of the two sets A and B. Okay? If you look back at the other example where we're asked to find the intersection, there was just a smaller part of this, but here all the elements belong to the union. A short while ago we joined two sentences with the word and that was called the conjunction, and now we talk about a disjunction. When two or more sentences are joined by the word or to make a compound sentence, the new sentence is called a disjunction of the sentences. So know the difference between conjunction and disjunction. Exercise 10 asks us to graph and write interval notation, x less than or equal to -2 or x greater than 4. Well, x less than or equal to -2 means we start at -2 with a bracket, and all numbers to the left of -2 that are smaller than -2 would be on the left here. And for numbers x greater than 4, we have a parenthesis here. And it would be the set to the right of 4. And then in interval notation, that means -infinity, comma, -2, and remember infinity always gets a parenthesis, and -2 has a bracket because we have x less than or equal to -2, union, and here we have 4, a parenthesis, 4, comma, infinity, going all the way to the right. So that would be the solution in interval notation. This is the interval for the left part, and this is the interval for the right part, and we write that with a union. In exercise 11, we have x minus 4 less than -3, or x minus 3 greater than or equal to 3. We solve each inequality, so we add 4 to both sides here. So that means x is less than 1, or here we add 3 to both sides. X is greater than or equal to 6. So graphically, it means we have from 0 to 1, from 1, x less than 1, that would be this part here, and all the way to the left. And then x greater than 6 with a bracket, because it's greater than or equal to 6. That would be this part here. So then in set notation we can write the solution as the set of all x such that x is less than 1 or x is greater than or equal to 6. And in interval notation it would be from minus infinity to 1 with a parenthesis because it's less than 1, union the set from 6 with a bracket to positive infinity with a parenthesis. So here we have set notation, and this will be the solution in interval notation. Let's look at exercise 13, one of those guided solution ones. So here we have minus 3x minus 7 less than minus 1, or x plus 4 less than minus 1. So to isolate the term minus 3x, we add 7 to both sides, so plus 7 here and plus 7 there. And then, of course, we only have minus 3x because minus 7 plus 7 is 0. And on the right side, we have 7 minus 1, which would be 6. Then, to isolate x, we divide both sides by negative 3. So, and since we are dividing by a negative quantity, we're dividing an inequality by a negative number, we now have to change the direction of the inequality symbol, and it goes in that direction now. And then we cancel the minus 3's. We only have x left on the left side. And then 6 divided by minus 3 is negative 2. The other part, x plus 4 less than negative 1, here we subtract 4 on both sides. So x would be less than negative 5. Okay, so in the end we have x greater than minus 2 or x less than negative 5. So then the solution set is that x is less than negative 5 or x is greater than negative 2. And in interval notation, then the infinite interval from minus infinity to negative 5 to the interval from minus 2 to plus infinity. And the reason why we start out with this expression, x less than minus 5, and not with this one here, is because minus 5 is less than negative 2, and we typically begin with the smaller numbers on the left and then go to the right with a greater number. Exercise 14 says 5x minus 7 less than or equal to 13, or 2x minus 1 greater or equal to negative 7. So when we add 7 to both sides, we get 5x less than or equal to, and 7 plus 13 is 20. Now we divide both sides by 5. So that means we now have x is less than or equal to 4. On the right side, we add 1 to both sides to eliminate the minus 1. So that gives us 2x greater than or equal to minus 6. Then we divide by 2 on both sides. So we isolate our x. So x is greater than or equal to negative 3. So when we graph these solutions, we find that for the first one here on the left side, x less than or equal to 4, so that's all the numbers to the left are 4. And so let's do that. And when we graph the solution to x greater than or equal to negative 3, that would be all the numbers to the right of negative 3 that are greater than negative 3. And so what we discover then is that the solution set is a set of all real numbers. In other words, we make this whole line a solid line to represent a set of all real numbers. So to make that clear, we can write all real numbers. And what it really says is that pick any number and it'll satisfy this inequality or that inequality or both. For example, 0 would satisfy both inequalities. Okay? So maybe that's a surprising result, but that's what sometimes happens. Exercise 15 relates to a previous example in the book, number 10. And so number 15 asks, what square footage can be rented for a budget between $2,000 and $3,200? So example number 10 was this one here. The equation R equals 2 times S plus 70 can be used to determine the monthly rent R for an office with S square footage in a renovated commercial building. All utilities are included in the monthly payment. A florist shop has a monthly rental budget between $1,720 and $2,560. What square footage can be rented and remain within the budget? So what's changing to an example number 15 is simply the budget. It's different. It's between $2,000 and $3,200. So if you study example number 10, so the rent can be determined by this equation, 2 times S plus 70. And so to keep it within the budget, it would be then the rent can be between $2,000. So we can say R is between $2,000 and $3,200. Okay, so that's what we are told. Now what is R? R is equal to 2 times S plus 70. So we can rewrite this now as 2,000 less than 2 times S plus 70 less than 3,200. Okay. Now, one of the things you can do here, even though typically we don't use the multiplication property of inequality until the end, in this case it's a good idea to use it right away to divide everything by 2. Right by 2. Right, middle, and on the left. And that simply makes the numbers more manageable. It makes the numbers smaller, as you will see. because 2000 divided by 2 is 1000, less than, then the 2 drops out, we only have S plus 70, less than, and 3200 divided by 2 is 1600. And now all we need to do now is subtract 70 in each part of the inequality. So then that becomes 930. No dollar sign here. So the answer would then be between 930 square feet so maybe I should write between to make it clear, between 930 square feet and 1530, 1530 square feet. So here's a nice application of compound inequalities. And this is the end of section 1.5.